ఆగుమా నువ్వు కాస్త. Good morning to all of you. Welcome to Unacademy EAMCET YouTube channel. Good morning to all of you. Welcome to Unacademy EAMCET YouTube channel. Myself Vysali Karumanchi, Chemistry Educator of Unacademy. Very good morning, Chetan. Good morning to all of you. Welcome to Unacademy. Okay. I did my Masters in Analytical Chemistry from Andhra University campus. I had 13 years of teaching experience in EAMCET, AIEEE and NEET mains levels. Present working as Chemistry Educator of Unacademy, and this is my code VYSALILIVE. Very good. Congrats, Chetan. Unacademy is giving the best plans for the students who are writing EAMCET in 2021. So these are the plans for the students for the 2021 aspirants. This is of 12 months plan of 12,375 and 6 months plan will be 10,125 rupees. There is already 6 months full syllabus coverage batch is there. To enroll in that batch, use the code VYSALILIVE so that you can get 10% instant discount. And there is also 8 months comprehensive full syllabus coverage batch is there. To enroll now in this batch, use the code VYSALILIVE and you will get the 10% discount. And this comprehensive batch for the EAMCET 2021, that will be of the PCB, Physics, Chemistry, Biology and Physics, Chemist, Maths. So already batches are started for the Telugu medium students of 2021. To enroll the batch, use the code VYSALILIVE. And what are the advantages by taking of these plus courses? Look at this. In this case, premium content will be provided at the affordable price, that is minimum of the price. And second one is the structured live courses, dedicated live doubt clearing sessions will be there. Third one is quizzes at the regular intervals. That means for every completion of 1 hour, for every completion of one course, there will be quiz, mega quiz or the weekly quiz for the self-analysis of the students. And here it is, complete batches are there for their preparation, test series for the DPPs, full length mocks with the analysis. And already by taking of this single subscription, you can get the unlimited access to watch all the videos of all the subjects from all the educators. Everything will be possible under the single plus subscription. Look at this, 20 plus top educators are present in the Unacademy platform of the EAMCET. 10 plus batches are there, 250 plus courses were published, 2000 plus lessons, everything will and many more added every day. So look at this. This is the Telugu batch of the TS and AP EAMCET 2021. These are learn from the best educators for the EAMCET 2001, and every concepts and the tricks and tips are given in the Telugu medium for better understanding. For complete syllabus coverage, tips and tricks will save you the time and score better marks in the exams. This has been already started from 12th October. To enroll now in this batch, use the code VYSALILIVE, and Unacademy introducing the 1 month trial plan that will be of the 2,250 rupees. Use the code and you will get 10% discount. So these are the educators who are taking of the Telugu medium batch for the EAMCET 2021. Look at this. Myself Vysali Karumanchi. This is of code VYSALILIVE, so that you can get access. You will get a 10% discount for the plus subscription. And here I am giving you my plus class timings will be 8 AM to 9 AM, and already the courses for this October month will be noble gases, second one is the amines, third one is the chemical kinetics, and the fourth one is the solid state. Already this noble gases was covered and amines almost done. Chemical kinetics and solid state will going to conduct in the plus classes. And my special class timings will be daily of 12 PM to 1 PM. And today there will be the mega quiz on the noble gases at 5 PM to 6 PM. And tomorrow will be the solid state part 2. Yesterday I covered the solid state part 1 of the solid state. And tomorrow will be the solid state part 2 at Monday 12 PM to 1 PM daily in the special classes of Unacademy app. Yes, and MCQs on the amines will be Monday at 5 PM to 6 PM. And coming to the solid state part 3, Tuesday at 12 PM. Mega quiz on the solid state will be Wednesday at the 12 PM. So this is my timetable in the special classes of Unacademy. Now today I am going to discuss about the paper 24th September. Today the discussion is about of 24th September. 24th September. Shift 1 paper of medical students, agriculture. Am I audible and am I visible to all of you guys? Shall we start the session? First question. Look at the first question. Using Brady's arc method, which of the following metallic salts cannot be prepared? Using Brady's arc method, which of the following metals cannot be prepared? This is the question of the surface chemistry. This is of the question of surface chemistry. In the surface chemistry, we will prepare the colloidal solutions by using of the different methods. Among them, first one is the Brady's arc method. In this Brady's arc method, we will take the electrical arc, we will take the electrodes, and there will be the arc presented in between the electrodes, and electric current is passed. We will prepare the metallic salts like silver, gold, and platinum. By using of Brady's arc method, we can prepare the silver salt, gold salt, and the platinum salt, and this will be kept at the ice cold temperature. This will be kept at ice cold temperature. And what is the principle involved here? It is, first one is dispersion takes place. First one is dispersion takes place. After that will be condensed by using of the ice cold. So we cannot prepare the Brady's arc method, the sol is of sodium. We can prepare platinum, gold, and silver salts can be prepared by using of Brady's arc method. Very, very important one. Is it clear, guys? Next question, 122. Ammonia reacts with the sodium perchlorate, NaOCl. So look at this. Which product will be formed here? Any guess? Ammonia react with NaOCl so that it will forms into NH2Cl along with NaOH. Again this ammonium chloride react with NaOH, which is react with ammonia, so that it will convert into the hydrogen N2H4. along with here N2 H4Cl along with NaOH and HCl. Is it clear, guys? And this will be treated with NaCl and H2O. So the formed product will be the hydrogen. Next question. So we will look at the option NH2. NH2 is the hydrogen. And what is the third question? Look at this. Which of the following elements has the most negative electron gain enthalpy? Most negative electron gain enthalpy. Here they are giving the four options. Look at this. Neon 10 plus 2, 12 and 14. 14 element is the sodium, magnesium, aluminium and silicon. Right? So this will be of the silicon. Here will be the 16. Phosphorus, sulfur, chlorine, argon, potassium and calcium. Here it is 11, 12, 13, 14, 15, 16 and 17, 18, 19, 20. Look at this. This is of the 16. 16 indicates that this will be of the sulfur. And coming to the third one, this will be of the phosphorus. And here look at this. In this case, here it is. This is of 10 plus 2 plus 5, which is of 17. 17 is of the chlorine. And here look at this, 10 plus 2 plus 16, which is of 18. 18 indicates that argon. Yes, this is already stable configuration. And in this case, by taking off one electron, chlorine will attain the stable octet configuration. So in this case of halogens, we can say that fluorine, chlorine, bromine, iodine, all these are having the negative electron gain enthalpy. To attain the stable configuration. Is it clear? So the correct option will be the chlorine. Chlorine is having, generally we can say that halogens are having the negative electron gain enthalpy. Next one. Look at this. Which of the following statements is incorrect from the viewpoint of the molecular orbital theory? Here they are giving the four points. According to the molecular orbital theory, we have to predict the incorrect statement. First one is Be2 is not a stable molecule. And second one is He2, helium-2 is not stable, but He2 plus is expected to exist. Third one is bond strength of N2 is maximum among the homonuclear diatomic molecules belonging to the second period. Now, in this case, the order of the energies of molecular orbitals in N2 molecule is, we have to predict the incorrect statement from the molecular orbital theory. Beryllium is not a stable molecule because beryllium is having only of the 4 electrons. So it is not the stable molecule. In the case of He2 is not stable because He2 is having the bond order is 0. That's why this is not the stable molecules, but He2 plus exists. So here it is. Third one is bond strength of N2 is maximum among the homonuclear diatomic molecules of the second period. In the second period, the nitrogen is having of the triple bond. That means bond strength is very, very high. Bond strength is very high in the second period. Right? So this is also the correct statement. And what about the order of energies of molecular orbitals of the N2 molecules? Look at this. In this case of nitrogen, it is having of the 14 electrons. For the 14 electrons, write the molecular energy level diagram. for the filling of the electrons. Here look at this. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, and the next one is, here look at this, whenever the electrons are 14 electrons less than or equal to 14 electrons, then pi 2py equal to pi 2pz will comes in the first energy level. So look at this, after that pi 2py equal to pi 2pz for the filling of electrons, and the next one is sigma 2px, and the next one is sigma star 2px, which is followed by pi star 2py equal to pi star 2pz. So fill the electrons in these orbitals, in these energy levels. Right, here look at this. For the nitrogen molecule, they are giving the order as sigma 2s, sigma star 2s, sigma 2pz. But this is the incorrect statement. Here the correct statement will be pi 2py equal to pi 2pz will comes the first in the energy level. Is it clear? Next one. So the correct option will, incorrect statement will be the D here. Next one. Products P and Q in the following reactions respectively. Phenol reacts with the zinc metal, which is followed by the heat. Which product will be formed here? And in the second question, phenol react with the sodium dichromate in the presence of the acidic medium. Which product will be obtained? Hi Harita, welcome. Welcome to the Unacademy. Join the session, Harita. Phenol react with the zinc metal in the presence of the heat. Which product will be formed here? Again, in the second question, phenol reacts with the sodium dichromate in the presence of acidic medium. Which product will be obtained? Here, look at this. We won't look at the options. We will try to solve the questions, right? So look at this. Phenol is treated with zinc metal. Phenol is treated with zinc metal which is followed by the heat, so that the benzene structure will be obtained. Benzene structure will be obtained. And in this case, phenol is treated with a dichromate, sodium dichromate. This is very, very important one. In this case of sodium dichromate is a strong oxidizing agent, so that it will be converts into the, here it is, the bonds will changes. The bonds will be like this. This is of the paraphenol. Now we will look at the options here. Look at this, benzoquinone. So this is the benzene and here it is the benzoquinone. Is it clear, Harita? Benzoquinone. So this is of phenol is treated with the zinc metal. Whenever phenol is treated with the dichromate, then this will be of the benzoquinone. This is the structure. Sodium dichromate acts as a strong oxidizing agent. Next question. The role of catalyst in a reversible reaction. What is the option here? The role of catalyst in a reversible reaction. First, we will check the options. Changes the entropy of the reaction. Second one is increases the rate of forward reaction, reduces the time required for reaching the reaction equilibrium state, and decreases the rate of reversible reaction. Here I am taking this reversible reaction. Is this reversible reaction, Harita? This is the reversible reaction. Now, A to B is the forward reaction. A to B is the forward reaction. B to A is the backward reaction. Now, we are using the catalyst. What is the role of catalyst whenever we are used in the reversible reaction? That means it decreases or reduces the time for reaching the equilibrium state. Whenever, here I am drawing a graph like this. Here look at this. This is of the, here I am placing this two equations. This is of absence of catalyst, and this is of catalyst used, presence of catalyst. Look at this. This is the equilibrium point, right? This point is the equilibrium point. Whenever we are using the catalyst, then it reaches the equilibrium in less time. whenever we are not using the catalyst, we will attain the equilibrium in the large time. So it reduces, the catalyst reduces the equilibrium reaching point. Okay. So this will be the role of catalyst. Okay. Presence of the catalyst, it will increases, it will reduces the time of the reaching of the equilibrium state. No issue, Sarita. Continue. Okay. So this will be of the third one is the right one. And next question is, in a face-centered cubic arrangement of A and B atoms, where A atoms are at the corners of the unit cell and B atoms are at the face center, 2 atoms are missing. Now look at this. Here A atoms are there, B atoms are there, right? This is of the simple cubic. Simple cubic. Now, in a face-centered cubic arrangement of A and B atoms, where A atoms are at the corners. So look at this. Here I will change the color. These are the black are the corners of A. Yes, this will be the corners. Now, B atoms are at the face. B atoms are at the face. Now here I am taking this faces. Blue color as the face. How many faces are there? Total 6 faces are there. So here I am placing 6 faces. Okay. Corners are 8 corners and faces are 6 faces. Look at this. Corners, A is located at the corners A and B is located at the faces, 6 faces. Now here the question asking that from the corners 2 atoms are missing. From the corners 2 atoms are missing. Right? That means A is only 6. A is only 6. B will be the 6 here. Right? Now look at this. In the cases of corners, that will be 8 into 1 by 8. Now here only 6 atoms are present. That is 6 into 1 by 8 plus faces. How many faces? 6 faces, and each face is divided in between half. So we can say that 6 into half. Right? So look at this. This will be of the 3 by 4 is to 3. Can we take it as 1 by 4 is to 1 and 1 is to 4? This ratio A is 1 and B is 4 here. The structure will be AB4. We will see the option. Yes, this will be of the AB4. Is it clear? Next question. The structure of Marshall's acids among the following is. The structure of Marshall's acid among the following is. In the case of Marshall's acid, here look at this. Marshall's acid formula is H2H2O8. H2H2O8. Here 1, 2, 3, 4, 5, 6, 7, 8. Okay. H2H2O8 is the Marshall's acid. Now, whenever the structure will come like this, you have to check whether peroxy linkage is present or not. How can we check the peroxy linkage? How can we check the peroxy linkage here in any compound? Look at this. To find out the peroxy linkages, first you have to find out the oxidation state of sulfur. Here look at this. 2 plus sulfur is of 2x minus of 16, which is equal to 0. 2x equal to 14, x equal to 7 here. Generally sulfur will exhibit of plus 2 to plus 6 oxidation state. Whenever any element is in between the oxidation state, corresponding oxidation state, there will be no peroxy linkage. There will be no peroxy linkage. Here look at this. This sulfur is exhibiting. This sulfur is exhibiting of the 7 oxidation state is out of the oxidation state of sulfur. So it will shows the peroxy linkage. It will shows the peroxy linkage. Ela find out chesina peroxy linkage ikkada meno ఏదైనా ఆక్సిడేషన్ స్టేట్ అనేది ఇన్ బిట్వీన్ రేంజ్ ఉంటే కనుక that will not present the peroxy linkage. Whenever the oxidation states lie out of the range, that is said to be the peroxy. So look at this. In this case, sulfur is exhibiting the +7 oxidation state. It is out of the oxidation state of sulfur. So it will showing the peroxy linkages here. Yes. So in this case of peroxy linkages, we will write the structure. That means sulfur, oxygen, oxygen and sulfur. Now place this double bond oxygen, and here look at this, how many, 1, 2, 3. Here it is OH, here it is OH. So there is a peroxy linkage. So this is the structure of Marshall's acid. Is it clear? So this is the exact structure. Now next question. Find the electrode potential for the given half cell reaction given below at pH equal to 4, and the reaction is given by 2H2O gives rise to oxygen plus 4H plus 4 electron. Reduction potential is given as 1.23 volts. Given R value equal to 8.314 Joule Kelvin inverse mole inverse. Temperature is of 298 Kelvin. Oxygen is under standard atmospheric pressure of 1 bar. We have to calculate the electrode potential for the given half cell reaction. Now look at the options. Here it is 1.53 volts, 1.53 volts, 0.99 volt, minus of 1.01 volt, and the fourth one is minus of 1.23 volts. Now look at this. Here given equation is of 2H2O gives rise to oxygen plus 4H plus 4 electron. This reduction potential is given by 1.23 volts, right? So look at this. This 4H plus, by gaining of 4 electrons, it will be converted into the 2H2 gas, hydrogen gas. For hydrogen gas of oxidation potential is equal to 0. Is it clear? For the hydrogen gas reduction, reduction potential is of 0. Reduction potential is 0. Now we have the formula. Here it is E cell equal to E naught minus 0.0591 by N into log of product by reactant. So look at this. E cell equal to E naught value is given 1.3 minus of 0.0591 by N number of electrons. Number of electrons will be, here it is 4 electrons into log of product is of KpH2 square by here pressure is given. That's why we are taking off the partial pressures, right? Pressure of H2 square by pressure of H plus. H plus is of the 4 times. Now look at this. In this case, this value pressure of H2 is given as 1 bar. Pressure of H2 is given as 1 bar. Now look at this, 1.23 minus of 0.0591 by 4 into this H plus will go upside into minus of 4 of log of H plus. So 4 will be cancelled. And this H plus pH value is given as pH value equal to 4. H plus concentration is of the 10 power minus 4. Substitute the value here, that is of 1.23 minus 0.0591 into log of 10 power minus 4. That is equal to minus of 10 power minus 4 is equal to 1.23. Here I will write 1.23 into 0.0591 into 4. That is equal to minus of 0.099 volts. So this will be the correct option. Is it clear? Next question. If the solubility is represented as S moles per liter, solubility product as KSP, the relationship between two for zirconium phosphate. Here given salt is zirconium phosphate. Look at this. In this case of zirconium phosphate, whenever any salt is given, then that will be completely dissociates into ions here. Look at this. Here I am taking this ZR zirconium phosphate will be dissociates into 3 ZR plus 4 plus 4 PO4 3 minus. Now look at this. This will be 3S plus 4S. If any salt is given, then here I am writing this one AB, A plus XA plus YB, that is equal to XS plus YS. Then X power X, Y power Y into S power X plus Y. This will be the solubility product formula. So look at this. KSP equal to 3 cube into 4 power 4 power S power 3 plus 4. We have to write the relationship between KSP and the SP solubility. So look at this. KSP equal to 3 cube. 3 cube means 27 into 4 4s are 16, 64. 64 into 4, that is equal to 4 4s are 16, 256. 256 into S power 7. So look at the options. So sulfur solubility and KSP. Solubility equal to S power 7 is given. KSP equal to S power 7 into 6912. So sulfur solubility equal to KSP by 6912, and this solubility is given as KSP by 6912 power 1 by 7. So this is the correct option here. So this is the last question. And we will discuss the next question 31 to 160th questions in the next session. Thank you for watching this session, and subscribe this channel and share the session with your friends, and enable the bell symbol.